Dangal, greetings. I am Jasmine Atienza and I will be the one further explaining our paper in regards to the chosen tool of our group. Since we all know physics is one of the most important subjects for engineering students, especially those studying electronics engineering, it's also one of the hardest because of the complicated calculations and concepts involved. Many students spend hours solving equations and trying to understand how theories work in real-life situations, which can be frustrating and time-consuming. To help with this, we created a general physics tool. This program, made using Python, is designed to make solving physics problems easier and faster. It covers topics like kinematics, projectile motion, Newton's laws of motion, and work energy principles. By doing the calculations for the students, the tool allows them to focus on learning the ideas and understanding how the solutions work. For our objectives, this tool was made since the math involved in physics is so tricky that it can discourage students from learning. The general physics tool was created to make physics easier by solving the hard parts for students. It helps with calculations for things like speed, acceleration, and energy transformation so that students can focus on understanding the concepts instead of getting stuck on the math. It is designed to be easy to use so students at any skill level can benefit from it. By connecting the theories they learn from it in class with practical problems, this tool helps students feel more confident in tackling real-world challenges.
Dangal, greetings. I am Justine M. Basilio and I will be quickly explaining how our general physics tool works. First is display options. The function presents a clear list of choices, each numbered for easy selection. These options might include kinematics, average velocity, average acceleration, projectile motion, parabolic motion, Newton's law, and many more. Next is to get the user input. The user is prompted to enter a number corresponding to their desired choice. The program validates this input to ensure it's within the range of valid options. Second is the call for relevant functions. Once input is validated, the program jumps to specific function associated with the user's choice. For example, if the user selects the corresponding value for kinematics, the program would call the kinematics function. Lastly is to solve another or exit. This option allows the user to either perform another calculation or terminate the program. It works by validation. It checks if the user's input is a valid integer, ensure the integer is within the range of valid options, and if the input is invalid, it displays a clear error message such as invalid input. Please enter a number again. After displaying the error message, it will prompt the user to enter a valid input again. That's all for me, and the following will be explained further by the next presenter.
Dangal, greetings. I'm Rechie de Guia and I'll explain how the glossary, notes, and exit features work in our general physics tool. First, let's discuss the glossary. This part of our code acts like a dictionary, allowing users to look up physics terms and their definitions. Some of the physics terms included in our glossary are force, energy, velocity, acceleration, work, power, mass, weight, and many more. When a user enters a keyword related to physics, the code checks if the keyword exists in the glossary. If it does, the definition is displayed. For example, if the users enter power, the corresponding definition is printed since power exists in our glossary. If the keyword isn't found, a message stating no keyword for this word is shown. The user is then asked if they want to search for another term. If they choose N, the function exits and returns to the main menu. Next, the note features provides a simple note-taking system. This part of the code offers a menu with 3 options: writing notes, reading notes, or returning to the main menu. In option 1, users can input their notes, which are stored in a file named pythonnotes.txt. If the user chooses option 2, the contents of the file are displayed, showing any previously saved notes. Option 3 allows the users to return to the main menu. If an invalid option is chosen, an error message prompts the user to enter a valid input. The function continues running until the correct option is selected. And lastly, we have the exit option in our code. This part of the code allows users to terminate the program. When the user selects 11, the program prints program exit and uses the exit function to stop running, effectively ending the program. After this, the program closes and no further actions can be performed.
For the last part of our presentation, allow me to discuss the applications of our topics in making this final project. For the first part, we used while loops in making the menu and almost every function on the general physics tool because it allows the user to prompt as many inputs as they want, and the code will generate the answer as long as it satisfies the condition on the code. Here are the parts of the code that we used while loops on. Next topic used is list. It is showcased on our code on the average velocity and acceleration, as the formula for those needs multiple values to be calculated, in which list is used on storing values on the code. Here is the part that list is used on. Another function on our project that we have is dictionary, in which of course shown in the latter part where the glossary is. In this part, you'll be able to know the meaning of the word just by typing it. Another application used is function. It is used to handle errors in user input for the code. To be able to avoid error, we use the def function in this part to ensure a precise and correct answer. Here is one of the parts that used function on our code. Another function that this project has is reading and writing notes. Using Python notes.txt to enable the users to perform reading and writing notes while solving. With the help of Python notes.txt in this code, the users are able to read and write notes that can be accessed and saved for later use. For the last part, the if-else statement. The if-else statement is there to help the program to decide to accept or deny the user input. It is mainly found on the whole code, but I'll just use the code for reading and writing as this also showcases the if-else statement. Unlike if the user inputs numbers from 1 to 3, it will prompt an option to write, read notes, or go back to the menu. While if you input another number than 1 to 3, the program will respond that your input is invalid and it will prompt the user to enter another number. And that is all for this presentation for our final project for UCPNC student Physics General Tool. Thanks for watching.